This conference will now be recorded.
Okay, so this is where we left off last week. We discussed the definition of ownership, the ability for the consumer to authorize updates to the device firmware or configuration, and then ownership transfer was making somebody else the owner, giving them this capability. Couple of things fell out of last week's discussion. One was that transfer of ownership is not optional. I think the capability, and I think we agreed that that would be determined by the security level and requirement spreadsheet, not necessarily part
Well,
of the spec to determine what's optional, not optional.
I mean,
This
if there's a device that only ever runs vendor firmware and no one's actually interested in running their own firmware on it, does it need to support ownership transfer? I'm thinking like something really low level, like a fan controller or something. I don't know.
Yeah, so I think is there? It's a good question, Jeff. Is there, what if you have a mixture of devices that some do and some don't perform ownership transfer? You
Right.
know, does the owner
Well, it
have
should be
security
illegal.
device? You know,
The microcode example is good, or you may have low-level bootloaders that, for regulatory reasons, need to be closed, or libraries that need to be closed while the rest of the system is open.
or we could confuse in like ownership transfer with authorship in that sense, because when we looked at like that microcode case, um, there was this option where the manufacturer firmware signature would be controlled by this provisioner key, um, and that would enforce these kind of genuine updates to the device. That was orthogonal to to ownership transfer, where you had a signer, essentially a device updater, who was authorizing that update. So
The question I have is like,
kind
do
of
you need
signal.
to push all that? I'm sorry.
Oh, that was kind of this dual authorization versus signal authorization. I thought the manufacturer signature for things like microcode was this kind of was forcing down this dual authorization, and then there was an option here, which maybe this is kind of counter to the capability, but there was an option for consumers to choose to leave it as manufacturer only.
Is it? I mean, it seems like we could make life easier on the manufacturers if we like say we are if we empower say a BMC to make those kind of can you update the firmware or can't you decisions, and then the device just takes whatever firmware is given it, and as long as it's signed by the vendor, it's all good. That seems like a legal configuration, but I don't know. What does everyone else think?
Okay.
Like if we
So
scope ownership transfer like authorship, does that make this all simpler?
Then
um,
isn't that just making the BMC the owner or the updater? I'm not sure
And
which
then
in that example.
yeah,
and then you could
that
say, okay, only someone's allowed to run code on the BMC. I don't know.
So the thing is that I think we have talked about three different things that you can do with ownership, right? One is this ability to authorize authorship, which may or may not be there, right? Depending on the device or depending on what the manufacturer wants to do with that device. The second one is we said there are potentially some configuration settings that only the owner should do, right? And the only one I can think of at the moment is ownership itself, right? And then the third one is an ability to onboard a device or be able to prove to others that the device has gone through some sort of acceptance into that data center, right?
Yeah,
So,
I don't really get the third one. Is the third one just attestation?
the third one, I think, is it may be something like, for example, you take the identity certificate and you create a new one and you sign it locally. And maybe you provision it into the device if the device has the ability to store certificates. And then your verifiers are not going to check the identity of that device based on the manufacturer's cert, but based on the data center certificate, right? It's just basically a way to say, I took this device, it went through my onboarding process, and I can prove that it's mine, so to speak.
I see.
For
But again, is that doesn't give anybody the ability to apply an update or to prevent an update.
Correct. That's what I said. There's three different things that you can use ownership for.
I see.
And then what I was getting at is, if you don't have a need for any of those three things, and I don't know if there's others, but if you don't have a need for any of those three things, then maybe you don't need ownership, right? But if you need to be able to configure certain things or one of those three things, then you need to have ownership or support ownership.
It seems like that third option, is that not simply some storage on the device? Because I guess just for what it's worth, when we ingest parts that have manufacturer certificates, we don't intend on countersigning those. We'll just know in our control plane what manufacturer it routes back to, and then the verifiers can check with something off machine if we want countersignature.
So I agree, it's primarily storage in the device, but the question is, who is authorized to overwrite that in the device? And in that case, this is where the concept of ownership becomes important. Only the owner can overwrite it. So the device would have to enforce somehow that, right?
Yeah, if you want to defend against like a DOS attack by someone overriding your cert.
Right.
Okay. So I kind of I highlighted those three in the bullet, which is kind of like some real-time note-taking at this stage. So I think, Alberto, I just added that third point to claim device identity. That was not in the definition of ownership. And then transfer of ownership is, we're still keeping that definition as making somebody else the owner. The optional, not optional thing, I think last week, as I said, we decided that this should be determined by the bronze, silver, gold kind of levels of security. Like all the other security requirements. There was a little bit of... You want to talk more on this point?
Well, it's like, again, like, is a device less secure because it only runs vendor firmware if no one actually interested in changing owner?
Potentially, yeah, absolutely it is. 100% it's less secure. No doubt about it.
That doesn't seem obvious to me.
100% it's less secure. Okay, so you have a device and you've had the privilege of being able to review vendor firmware A. You own that device and you're kind of comfortable with it and you're really happy that you've got that device running vendor firmware A and you've reviewed every line of code in vendor firmware A. You haven't reviewed any code in vendor firmware B because you don't know about it, because I bribed the vendor to create that for me personally. So you go for a coffee, I jump on your laptop and I update it with vendor version B, and I tell it to, encrypt your hard disk with my encryption key, and then I charge you $50 for me to unlock it for you. There's a scenario.
And
There's a scenario where
that
it's less secure.
that kind of presupposes that the only thing standing between you and updating firmware is the device itself. There could be some interposer, some BMC.
Could be could be anything, like any kind of physical attack or even logical attack for that matter, where somebody else made a mistake in a line of code, had a buffer overflow. I knew about it. I took advantage of it. Yeah,
How is that any different when it's vendor code versus an insider from your own organization doing it to your own code?
it's absolutely,
Like, it seems like the same level of risk either way.
yeah. I can control the method by which an insider in my organization needs to obtain that signature. Does that make sense?
Yeah. But if they check in code that has, like, they purposefully check in code that has a buffer overflow in it, and now there's a perfectly legitimate bit of signed hardware by your internal methods, and they know the exact thing to exploit because they put it in there on purpose, that's absolutely no different.
Well, I can control that check-in process, right?
Yeah, but you're not going to catch everything, and they're going to be sneaky about it.
They have to catch it, don't they?
I'm confused here about our our objective. I thought that our goal as a security group and ownership is to make sure that the ownership that's required, for example, by the Open System Firmware Group, is carried out securely.
Yeah, that is Elaine, but I think where it gets a little bit vague is ownership, as in authorship, is a firmware. If you view it as authorship, and I want the ability to apply some open firmware to some device, I think that's maybe a little different definition of transfer of ownership than what we have here as the definition. So, if the definition is to authorize updates to a device firmware, or change the device configuration, or claim the device identity, then I think that's different to a scenario where you have a device which is usually fully custom, like a BMC, for example, which there's no vendor firmware. Where it gets a bit murky is when there is vendor firmware, and how that transfer of ownership interacts with that vendor firmware. And I think if you get selective with what is transferred and what is not transferred, then that's a slippery slope. Because all of a sudden I end up with a module in my VMC that is vendor provided, and then that goes away too. Which, by the way,
Elaine, what's your understanding of what the Open System Firmware Group believes ownership is?
So in their view, the low level, their objective is to be able to sell the system to someone else, right? And the other objective is that when this firmware is buggy or has gone, call it like a book out of print, right? It's no longer supported by the vendor, that they can take ownership, I'm using ownership in their terms now, and be able to debug and or replace that firmware. It's not a security statement. It's a, life cycle. Essentially, it's a life cycle and reuse issue.
But it's about authorship, right?
Yes.
Being able to author. Yeah. So I think that's the disconnect.
And relinquish that privilege to someone else.
So do we have a common understanding of ownership?
Yeah, our ownership is more, it's certainly more complex than that, but we have to make sure we accommodate what they need.
And they need the ability to author firmware.
They need the ability to control who the author is.
I see.
So they can author it themselves.
So I think that's covered by number 1 on the ownership definition we have here, right? It's just the only difference is we are saying that some manufacturers may not allow that, so then the device won't allow, right? And the example we used last week was Intel microcode, right?
Yeah, exactly.
They're not going to allow a third party, no matter who it is, to overwrite that. So then having ownership of a processor does not include 1, right? It probably includes 2 and 3, but not 1 in that definition.
Yeah, I don't know whether that's true of it though, because this is to authorize updates. I guess there's levels to it, right? You can authorize only legitimate updates. So, for us to authorize genuine updates to the OS firmware, yeah, that's possible.
Oh, okay. So I think there's 2 things within 1, and you're bringing up one that I wasn't thinking about, which is the cosignature type of methods that are used for saying this is signed by the right guy, but it's the version I'm going to allow to install, right? But then there's the other one, which is I'm going to be able to change the signature of the original author so that I can put any code.
Yeah.
So that maybe we need to add another one after 1 to separate those 2.
So what I tried to modify it, ability for a consumer to authorize genuine updates to a device.
But in our scenario, we have another step before that, right? We're authorizing the entity that then authorizes the updates. The owner, there's one more level, not just owner doesn't actually authorize the updates. The owner authorizes who can update.
Oh,
the owner authorizes who can authorize updates.
Well,
the owner also is going to authorize what versions can be used to update. I mean, if the owner can control the rollback policy and the port, like the firmware port download, port locking, things like that, then the owner can, between those 2 things, the owner can control not only, you might not be able to control whether a new version can be downloaded, but you can control that no older ones can be. And maybe if you extended it so that there was a specific list of firmware that could be downloaded onto the device that the owner could somehow securely put onto the device, then that would give the owner the ability to evaluate if, let's say, the vendor came out with a new version, that new version wouldn't necessarily be supported by that device until the owner had a chance to evaluate that new version and they said they trust it themselves.
I think the CPU is pretty interesting because we have these 2 different kinds of firmware running on it. You've got the microcode, which no one will ever author except the CPU vendor, but you could have other authorization on top of that. And then you have like the UA5 BIOS, which could be anywhere from no one signs it at all to, someone signs it and someone else countersigns it, anywhere in between.
Would you not consider those two separate devices in our world?
Well, it's one device with, oh, I see. Yeah, two separate devices you could. But there can be devices that have firmware on them, that a single device that there's some firmware that cannot be updated by the owner and some firmware that can. I mean, I could see somebody having a device that can run containerized applications, but nothing else, and all the other firmware on the device is 100% owned by the manufacturer.
So Elaine, you brought up something on the definition that I tried to capture. Is that the owner is the ability to control who has ownership? Was that right? Or who can apply updates or something? You
Who can
said?
apply updates?
Yeah. So then is that like a updates? Can they control who can make changes?
So the updates that we talked about long ago were the one piece of data that the updater controls is the firmware signing, the public key, and the other one is the critical configuration. Those were, so we had owner authorizes the updater authorizes the firmware signing key and the critical configuration. So it's the updater that really has a lot of the power, right? The owner is just, he's like the owner, but not the manager there.
He gives away capabilities. Mm-hmm.
Yeah.
But I guess in that definition, is the updater the author, or is that yet another party
That's one,
here?
But then there's one more step, which is the last one, which is the firmware signer, right? And
Ooh, I like that. So then we have like firmware signer.
mhm.
And the firmware signer could be just the manufacturer.
Could be.
What does the firmware signer do? It's firmware.
Just signs firmware. Yeah.
But
Is it the same as the author? Is that the author?
Not
No.
necessarily, I don't think.
Not
Like
necessarily.
It's kind of ambiguous because when you're like talking about countersigning, you have multiple firmware signers.
Mm-hmm. Right.
So we're being implicit about the policy here. We should get to the point where we're saying exactly when these are checked. I think that's what distinguishes them.
True.
These are
Yeah,
knobs on the policy support.
which signer or key is being used for the verified boot, secure boot? Which signature check is?
The firmware signer.
does the firmware signer, does he sign it in accordance with the update key, or what does he use? No, he uses a firmware signing key, doesn't he?
Yep, just firmware signing key.
Yeah,
But that signing key has to be signed by the platform key.
But the updater provisions the firmware signing key.
Mm-hmm. Yes. Now, one variant on here was, remember in the secure boot step, there is the concept of there's the firmware, toy boat. There's the concept of a manifest, and we defined a thing called a firmware keys manifest, which would allow a list of firmware signing keys, a list, not just one. You can have just one, but that's how we got through having we called it a key manifest. But that's in the secure boot spec, right?
Huh?
Yeah, right.
So,
Yes, it is. It is. But my question is I think do you call it a platform key? The main key? The key
So
that's in OTP,
like
for
in
example?
UEFI, a UEFI example, your PK, your platform key would be your updater, I believe.
But in the manifest option, the PK is used to sign the manifest as well.
So using UEFI, if we want to try to relate it to that, so UEFI would have a PK and a KEK and DBs in the simplest
Yeah,
case,
and
forgetting all
DB
the
and
weird
DBX.
cases.
But I
Yes.
guess my question then is, can the owner update the platform key? The answer would be the platform key is manufacturer only.
Right. So the owner would be able to do that. Yes.
all right, let's
No, the owner
let's
would update your KEK.
Yes, so he could insert a key into the DB.
Yeah, not the PK, because in the UEFI world, the PK is forever set. Although that is certainly one of the issues that the open system firmware folks have, is that PK is forever set. But if there's another means to get around it, I think they'd be fine as long as you can get around it.
Well, you can't bypass it.
Well, you could, if your KEKs rule at that point, maybe you can. I don't know.
But you have in UEFI, you have to have your KEKs signed by the PK. Your
Yes,
certificate.
and that's the issue for them,
Yeah.
that they don't want to do that, and that's why they have all the mock DBs and all that stuff.
Yeah.
Yeah, it can always be solved with another level of indirection.
So I forgot where we were when we went down this question.
Well, I think we got a little bit maybe more succinct than some of the differences that folks are getting maybe confused on, which was the owner, the updater, and then I think the firmware signer. That these are the definitions that go back to the specification, right? That were originally thought of like 2 years ago when we went through this. So it's good we're arriving back at the same point today.
So should you put author in there too? Because the author is necessary too, right?
Okay. Yeah.
Firmware author.
Yeah.
Yeah, you're right, because that may be different than the signer.
Yeah.
All right. I'd like to see us be a bit concrete about the byte streams that are being signed and the points in time we expect the signatures to be checked.
Ooh, flow diagram.
Well, for instance, because of an install image might contain initial state in otherwise read-write areas. The signature over the install image is going to be different than the boot time image, which will have to account for, you have to basically ignore or otherwise validate the read-write areas. And then something maybe we're not concerned about here would be the tooling around offering an update to a device that the host operating system or whatever operating system, the BMC, the data center management plane, may have a different delivery format that contains a bunch of metadata, and that whole package is signed. In cases where the manufacturer hasn't relinquished any control, that may be the only control that the data center operator has.
I see. I'm wondering though, does that like in your example of the BMC, does that like have any burden on the manufacturer for any of that?
If a manufacturer is giving a complete system and the BMC is driving updates to other devices within the system, then the metadata in the package that the BMC accepts, the whole thing needs to be signed. That may include, for instance, you may have multiple serial EPROMs, and is this package is destined for the one on bus 4, this target address, which the device itself doesn't care about, and that is a dumb device, not able to check its contents, but say a CPLD or an FPGA. So anyway, I think most people are thinking about boot time, but there are important differences with install formats versus boot time formats at least. And we should talk about what the byte streams are and what point in time those signatures are checked.
Yeah, I think that's a good idea. Because then at least at time t when you did the download, you knew the code from for that CPLD was good, even though that's never checked at boot time.
Ben, in our changes of ownership and keys and such in our systems, we use the EFI signature list formats to send those requests in. Are you talking about something like that? Or are you talking about what's the payload inside there?
Well, I just want us to distinguish these different policy points, code points.
Oh, okay. Like where along this life cycle
Like
these things happen.
this signature affects, the initial boot time check, and that signature over that byte stream is, maybe you use the same key, although generally it's not good to use the same key for two different purposes. Maybe use the same key as what you use to sign the image that you deliver to that device, but that delivery format is not necessarily the same as that delivery byte stream is not the same as the boot time byte stream.
Right. Yeah, one's a packaging and supply chain kind of thing, right?
In addition, I mean, you might have a byte stream that contains initialized data, initialized code, your initial boot policy, your A/B partition selection, what have you, a bunch of stuff that could change over the lifetime of the device while that device is still conforming. So that image byte stream is often different than the boot time byte stream.
And are you suggesting that because there are those different byte streams that they each deserve or need their own author?
No, I'm just saying that it's best practices for them to have different keys.
Right.
Just cryptographic best practices. Those keys can be coming from the same place. It's just that some of our, we're talking about update. Update is often a different byte stream than will be used for the boot time check. Owner, I think, is what I associate with is that boot time check, what is actually executing in my data center. Updater is the gatekeeper on to what gets installed. And then these others, I want to be clear about those as well.
So in accommodating that, our model would have multiple firmware signers.
Well, think about all the points at which you're going to check it. And are you checking the same byte stream? Are you using the same key? Do those keys come from the same place? What's the policy controlling those keys? We're talking I'm not convinced that all of us have the same mental model when we're talking about these things. And so we wind up spending weeks and weeks going over the same territory when we're probably all agreeing.
Yeah. we like to do that. So, do you think like a flow diagram, Van, would be
Yeah,
beneficial?
that would, yeah. When we talk about this is where the owner key comes into play at this point in the flow chart. That any flow diagram, anything that's going to properly represent the policy flows.
I thought that attestation specification kind of had that flow diagram, at least from where things got provisioned.
We do. We have that in the provisioning one. Yeah. I'm trying to find it again.
Yeah.
Good section.
Is Ben, do you feel there's more needed than that?
Well, I mean, owner ability to control. Maybe we need a subscript, but owner ability to control who can apply updates. That is the key that a device uses to accept it. Is that the key that the somebody uses to stage it? And is that the OS
Yeah, I think
level?
well,
I mean,
there's a
it's fine for it to be different things, but just be concrete about it. That's all.
oh, I see. Yeah, I'd always, at least in my mental model, it's always at the device because as soon as you make any security on the path to the device, as soon as you take a different path, it all falls apart.
Yeah, I'm not disagreeing with you there. You do need that control close to the point of use, but um, just like any multi-layered security scheme, I'd prefer to have early failures to say,
Yep.
this thing isn't even fit to bring over to the device and present it, and have a signature check there. Not that that's the final answer, but I would just prefer to fail early.
Yep. No disagreements there, I think. But there's when we talk about device capabilities or properties of a device, does it need awareness for any of that? Like in two of the paths to me, one of them is going to have some checks that causes an early
No,
failure. So we don't need to worry as much about it. So
no, and in fact, you should be fine. Um, in some sense, you should be fine having only that boot time check on the device itself. Assume again, you're going to run more efficiently if you can fail early.
yeah,
But if somehow a bad image gets onto the non-volatile storage of a device, I certainly want to reject that corrupt or otherwise invalid image.
yeah,
I completely agree that you need different signatures for update versus boot. I'm not seeing a compelling need for them to ever be a different set of keys because if you guard the update with a key that you don't guard with boot, then you fall into that situation that Brian's talking about where someone can just not sign it with the key you wanted but bypass your update and somehow flash it. If you're checking with a key at boot time that you're not checking at update time, that's a brick scenario.
True. So,
Yeah,
but you have to do both, and they are typically different keys. You're saying they don't have to be?
I'm saying I don't see a compelling need for them ever to be a different key. Like it could definitely be different signature because you might have some bits that remain that are zeroed out at update time, but then get whacked during boot, like with counters or logs or whatever. You certainly don't want to sign those and have it check at boot time. Could be useless. So you want different signatures for sure, but they need to be different keys.
Well, I think it's good crypto practice to not use the same key for multiple purposes.
Yeah, I would just ask a cryptographer to tell me what to do there. I mean,
and then I'd always tell you to use two different keys. Period. I think.
Yeah.
Because that's one of the basic tenet is to don't use the same key for different purposes.
It
I mean,
would,
Um,
I don't think it is
I
a
mean,
difference. It's just verifying the signature at two different points in time. He's
yeah,
verifying
you can use the same
yeah, I mean,
key.
for instance, you could have in the image, you could store two hashes. One is the hash over the full install image, and one is the hash over those sections to be checked at boot time. And you have the same signature check sign a manifest of those hashes, and that would be fine. That's one signature over one blob, and it's useful in those two scenarios.
Or if
That's it.
there's like a common header that clearly distinguishes this is a signature for the entire image versus this is a signature for the static regions.
Yeah,
That should
that's what I'm
yeah,
trying to say.
yeah.
Yeah, that makes sense. But then that has to do with the image and how you're initializing it and so forth, as opposed to which image you're putting on the device, period.
We might, I reviewed lots of vendor implementations, and there is so much variety for no particular reason. I mean, it's not a bad thing to have a suggested implementation.
Yeah, I think it's a good thing.
I think we'd all enjoy that. Just tell us how you want it.
Just tell us what to do until you tell me the wrong thing to do. Okay, so just getting back to the slide, we're pretty good, I think, with definitions. The owner, the updater, the firmware signer, firmware author, person that writes the code. Is that right? No?
Yep.
People have a definition? All right. Transfer of ownership, we agreed on that. This one, transfer of ownership, not optional. Do we make it optional? I don't know why this came up last week. It seems that the requirement spreadsheet would determine it. It determines everything else, it seems. Would we make ownership an exception to that? I believe, I don't know if you guys on. It's not. But Elaine, do you know if where this stands in like the requirements?
Yeah, it's if it's a main board, hang on, or there are two cases in which it's required. I have to go look it up. Keep going and I'll look it up and come tell you back.
Hey, Brian, the owner ability to control who applies updates, is that the same as the boot time check? Because that time of, this is a talk to, right? Time of update versus time of read, time of execution. Which of these is this?
I should probably maybe clarify it. So the ability to control who the updater is essentially.
And then what's the boot time check?
This is the updater has the ability to set the firmware signing key, and then the firmware signing key is the thing that
Okay, all right.
authorizes. Yeah.
Okay, fine.
So I think that's a good
Okay.
definition.
Sorry, so does this allow me to change who the firmware author is?
Yeah, we don't know who that is yet. That's a good point. It's kind of left there. It's a person that writes code. It's not really a good explanation.
Because in some cases you need to be able to change that. In some cases you really can't change that.
So would the author be the person that? How do we get a better definition for that?
Oh, well, you can have two. I mean, maybe we just need to break up ownership, or so there's different capabilities. You can change who the updater is. You can change who the author is, and some devices support both. Some support one.
I don't think the author actually
Matters.
plays into. I think this is a convenience for us to
Yeah.
to understand it, but it's really the signer from a security point of view that we really care about.
Yeah.
Sure,
We sort of
but
don't care who writes it.
Yeah.
that's fine. But like it comes. But same thing applies. Like in some devices, you cannot remove the vendor signing requirement, like microcode. In some devices, you totally need to be able to do that. Like UEFI.
I have the answer to your other question. So as far as requirements go, there are these apply to a system which is described as a motherboard or the main board of a system, and a card, which is a peripheral device such as a NIC, HBA, disk, etc. Okay, so those are who it applies to. And for a bronze badge, you need to have a key identifying the authority over updates. It doesn't say you have to be able to replace it, but it has to have one. And then for gold, so we jump from bronze to gold, does the product support authenticated ownership transfer? So that's from the security checklist, not the OSF one.
I see. So then it's required for like a bronze or gold, or a silver or gold. I didn't get that last part.
Bronze is only that you have to have a key for the updater. You don't have to use it. It's just that it's got to be there.
Okay.
And then for gold, you have to be able to do an ownership transfer, authenticated.
So that answers this. Transfer of ownership, not optional, symbol, or
It's right, not optional for gold, exactly.
that.
So is there a diagram that shows the actual ownership states? Like when you get a device, you have to take ownership, and then do we have a little flow chart that shows that?
Kind of. We have one like in the attestation specification because it was going through provisioning, which is where that was mentioned. But
Okay.
we're kind of getting into another level of detail because what we've realized is people have different ideas on owners, updaters, signers, and who writes the code and all this kind of stuff.
Okay.
I do think at some point, think about just what do we actually expect to do to these machines as they come in and out. Just like the implications of, for example, you can't require that you know who the actual next owner is when you decommission a device. That's like a hard requirement. So let's try and avoid mandating that in these definitions. So maybe we need to think.
But let's say I have a device, and if I have a device that comes into my system, I decide to not take ownership, that device still has to run securely, even if I don't take ownership. And I think that's all handled by like the secure boot spec and things like that. So, but then if I never took ownership of the device, then transfer of ownership becomes trivial as well.
Okay. Yeah, it didn't quite follow it, but if you never took ownership, you would just float it out the door and somebody else can do it.
Yeah, well, I guess what I'm saying is, what does it mean if I never what are the requirements if I never? I guess what I'm saying is a device has to have certain requirements when it comes in the door from a security standpoint. And then even if I don't ever take ownership of the device, which many people won't because they won't maybe understand what it even means to do that, but then therefore the device still has to operate in a secure manner according to its default security policies. So
yeah. I got what you're saying now. So I think we touched on that last week where some people may want a device, like what I call hands-off security, or just kind of turnkey security. We just make it secure for any kind of scenario and rely on the owner.
Okay, I see. You got that highlighted.
Yeah, okay. Owner.
Okay,
yeah,
perfect.
So I think we kind of had that one captured. And then, Jeff, you said something maybe there too, but I don't know if it captured it.
The update key sets the owner firmware signers, which are distinct from other kinds of firmware signers. Enforce what authorized updates can apply to device manufacturer, firmware signature for keys like microcode. Enforce what genuine updates can apply to device can be choose for manufacturer, to remain as owner, and main. And yes, that seems fine.
Okay. So this gets by this requirements spreadsheet. Get down here to the provisioner key sets the initial owner key, which is like a manufacturing flow. And then the initial owner, we said sets the device updater key. I'll plumb in the language from above in here, like updater. So the initial owner sets the updater. The update key then sets the firmware signer, which is then authorizing what updates get applied. We said in a case for things like microcode, the manufacturer has a firmware signature, and that's controlled at that stage by the provisioner, not by the owner. And that was an exception that I think Alberto raised last week. I don't know if he's still on, but and then to the last point that we made was the consumers may choose for the manufacturer to remain as the owner of all code. That's still accurate. Good recap of last week.
I think so.
Cool. So it's taken us 55 minutes to recap last week, but I think we got at this rate, it's going to take us a little while. I think we've all gotten to maybe at least a common understanding on the terms. The next question is, when is transfer of ownership applicable versus not applicable? And this gets into the maybe double clicking on the dual signature versus single signature requirements, and the microcode case, I think, is the only known exception right there. Or are there more cases where it would remain parts of code, I guess, would remain manufacturer signed? So, because we have this transfer of ownership where we're talking about an updater applying a firmware signer key, and the firmware signer key enforcing what updates get applied, and then we're saying except in the case of microcode. Is that accurate?
I mean, you can think perhaps maybe a root of trust device that the manufacturer doesn't want someone running arbitrary code on.
Yeah, there are other exceptions. I think it's up to the manufacturer, but
The-
something
the
I can
mic-
think of is there is, for example, a security module security code inside FPGAs that the manufacturer signs and doesn't expect that others will be able to change that, right? So has nothing to do with the bit streams that the FPGAs run, but it's some basic security that is used for guaranteeing the integrity of that FPGA, right? It's sort of along the lines of the root of trust coming, but it kind of goes beyond that.
Yeah. Board support modules like FSP from Intel, crypto libraries where there are regulatory rules come into play. Very, very low level bootloaders that are just finding the primary bootloader.
So you're saying that there's a plethora of exceptions where transfer of ownership is not applicable?
No,
Right?
I think it's transfer of ownership is fine. It's just that if you're the owner, you still can't sign some code.
But you should still be able to determine which versions of that code that you didn't sign can be used.
Right.
How do you determine that?
Well, I think you would have to somehow evaluate. Let's say somebody came up with a new version of code that you can't sign. So you could possibly evaluate that code, and then once you determined that it was fine and you accepted it, then you could change the DB or have some sort of using your rollback, anti-rollback or something. Or I don't know what the answer is, but you would have to be able to say, yes, this code is good, and I will allow it to be downloaded on my devices.
So are we saying this is always like manufacturer code, or is there some cases where it's not the manufacturer? Like, could it be like a previous owner or or an administrator or something?
Yeah, I guess it could be different things, but the most obvious one is the manufacturer. Manufacturer makes a new release. Do I want to pick it up or not? I don't want to just assume it's good. I want to evaluate it.
At the device.
Yes, at the device.
Yeah, because we talked about paths. And would that be like another signature? Or is there another mechanism?
Well, I think a lot of the device manufacturers wouldn't want to change their signing keys every time they make a new version of code. So I think you'd want another mechanism.
Like another signature over it?
I don't know. I don't have the answer. Or like a list of, like, you have a DB and a DBX of good keys. You could have like a DB and a DBX of good versions or something. I know it's a
But it
whole new
has
thing, but
The only mechanism I'm familiar with is the dual signature, right? Meaning the device is going to enforce the first thing that is going to check is that, for example, that the image that is being installed was signed by the local data center, right, or the local owner. And then if that passes, then it goes and says, okay, is this authentic code signed by the manufacturer? That's the mechanism I'm familiar with.
Yeah, that's a good mechanism. That seems really good.
So we're talking about this dual signature at update time, not at boot time.
Yes.
Okay.
And
Yeah, I
that's
mean, I
easy
think
to implement and manage that's easy to implement and manage for everybody. That works for the manufacturer and it works for the system owner.
Mm-hmm. Does that give you a vulnerability of like what's the if you have like updates that are checked, it's I always look at it as path to the device. If your path to the device is a boot, or if your path to the device is through somebody walking up with a USB key to it and sticking it into the device, or like if you only do security checks on one path, then you got a problem, or you got a vulnerability or a weakness. Yeah.
Well, I think I don't know who was speaking. I wasn't, but they said in that case, you first would check the signature. It would have to have the signature of the uh, owner of the system, and then it would have to have the signature of the manufacturer. Those things would both have to check out before the code was downloaded.
right. I mean, the way I've seen that is in the cases where the manufacturer doesn't allow changing its own signature, then that's somehow hard-coded inside the device, right? And there's a bunch of mechanisms for doing that. That the public key that's going to be used for that check. The second part is once you get the device, you can, and I think this is optional, you can optionally set an additional public key inside of the device that if it is set or when it is set, the device will also check. So it'll check both signatures, the manufacturers, and that additional key, right?
At boot time.
And that's the one, yes, at boot time or at installation time, right?
But those are, I mean, those are two different
Those are
mechanisms,
different
correct?
things. Yeah, I think you start with update and installation, right? And I'm not sure if you need to do this checks at boot. If you can ensure that you protect the image and that it can only be replaced on the device through a legal installation or update, right? But the point is, this additional resource is protected typically through this ownership stuff, right? Only the owner can set this public key, and it's changeable, right?
So this would be establishing an additional updater's key.
Kind of. It seems like that. It's like there's more than one firmware signer key. So we have a notion of firmware signer key. So it sounds like we have firmware signer key and then we have like manufacturer key, or I don't, that's why I asked in all of these cases, is it like manufacturer? Like there's like, or could it be like system administrator or somebody else? It seems like there's a firmware signer, there's multiple levels of checks or signature, I guess. So there's if it's probably easiest if it's, let's take the manufacturer case. There's like a manufacturer key or list of digests that, no, sorry, there's a manufacturer key that signature is always verified. Then there's an owner key that is evaluating or enforcing manufacturer updates, and that can be through like a list of digests or signature or one of those mechanisms. But that seems that this is more along the lines of the firmware signer. And what's missing, which is probably getting down to this whole author thing, maybe, I don't know, maybe the difference between author and signer is there's also in some limited circumstances, I guess, there's a manufacturer key which ensures that only genuine updates can be applied to a device.
It's almost like, in your second line above where we say authorize genuine updates. But number 2, modify device configuration, that is where we might lump the policies that you need 2 signatures, you can only have this key, blah, blah, blah. You have to have 1, you have to have 2. That might be where we can put that. And then it would fall under the updater's responsibility to control that.
Yeah.
Yes.
But then the updater, would they be always, would it stay true that the updater claims identity? If we separate
the identity cert?
Yeah.
I don't know. Stump me on that one.
Yeah, I don't think that would probably remain true as a role for the updater. It seems that like the owner, who's determining who the updater is, also, which starts out as the manufacturer, there's also this manufacturer key in there to ensure that, what the owner is applying to the device, including bits, that those bits are genuinely signed by the manufacturer.
Yeah, it's the owner it's either the provisioner or the owner that signs that identity cert.
So what I was thinking with the number 3, the device identity, wasn't so much who signs the cert itself, but who allows that cert to be provisioned into the device. What do you use to control that, right? And then that's what I was thinking. The updater is the one that says it's okay to put the cert into the device. Who signs it is sort of orthogonal to it, right? But the device will return that cert when it's doing identification, and the verifiers will have some way to validate that cert.
Let me think how to factor that in. Maybe we just need to have like a manufacturer key. Right?
Well, we
Like,
do.
where do we have it?
It is
It's kind
the public key is in the certificate, the identity certificate. Private key is protected.
yeah.
So the main reason for keeping that certificate signature sort of independent of anything in the device itself is because you may have different owners in different places may have either their own local CA that signs the stuff. The bigger CSPs will probably have that, right? And then there's a bunch of other people that maybe they go to a third-party CA, right? And maybe some of them go to, I don't know, VeriSign, and somebody else goes somewhere else, and so on and so forth, right? So maybe you don't want to hard code inside the device who those signers are. Simply hard code the ability to put a cert in there.
So you're talking about generating a certificate signing request for the identity key that's the private identity key that's in the device. Some
parallel cert. There's a cert that is signed by the manufacturer that says this is the device ID, right? You're going to create a parallel cert and you're going to get it signed. But the reason is, let's take two examples, right? Let's say Google and Amazon have this device and they generate their own cert, right? And let's say, for the sake of argument, that they're using the same CA, right? And that's some external CA, VeriSign, right? Then the cert is going to be signed by VeriSign, but in order to put, and of course the different certs, in order to put the one cert in the Google system, you have to have some Google authorization, not VeriSign. And in order to put the Amazon cert in the Amazon device, you need an Amazon authorization, right? Even though both of them are signed by the same signer.
Okay.
And this, I mean, again, like we would probably just design our systems to not require any kind of authorization and just deal with the potential for DOS in a different way. But that would reduce a lot of complexity on the device side, because then you don't need any kind of any need to provision keys, and you can just, as someone said, you can pass through your data center without having ever changed owners.
Yeah, I mean, I think there's two models, right? We've been talking about typically what you do inside of a device, and we're assuming that it sort of protects itself and so on and so forth. But there's definitely mechanisms where the protection of the device happens externally, right? And
well, for example, you take this cert, right? If we were to provision a cert, and you could, I don't know, put it next to the device on the same machine, and if the machine ever notices, oh, this device doesn't have its cert, let's go put it in there. That's kind of self-repairing. If anyone ever does unload it for whatever reason, we can just put it right back in.
Right. As a matter of fact, this particular cert, the identity cert, it doesn't have to be in the device, right? SPDM has ways of pulling it. You just have to make sure the verifier has it available, right?
Yeah.
So the verifier may decide not to pull it. Yeah.
Okay. Well,
yeah, it's only in the device as a kind of a way for anybody to be able to get it if they can't get it a different way.
It's a convenience, yes.
Yeah, convenience, yeah.
We're way over time, but I'll think about this manufacturer key some more and send out this note somewhere we're at so far, and then
Yeah.
maybe.
Check in the attestation spec. There's two diagrams that should be helpful. One is about the provisioning, all the provisioning and how the keys get in and out in there. And the other one is the certs. It's section 7, the cert chains.
I think the one is like the residual one that's left kind of behind by, like, we don't really call it out anywhere, I don't think, by the manufacturer for not overriding the firmware signer, but in addition to the firmware signer, there's this, how, so the firmware signer can easily evaluate what's a good manufacturer update, but we just don't call out really the manufacturer key anywhere, and I think that's maybe causing some confusion in some device, because it's in some devices. Again, it's kind of like this special case for microcode and these special bootloaders that Ben mentioned. Okay, something to think about.
Thanks, Brian, for dragging us through this.
We gotta get it straightened out. Yeah.
You bet.
Thanks a lot, folks.
Yeah, thank you, Brian.
Bye-bye.
Bye.
Right.
Thank you.